Welcome to this unit review for LT2 Learning Target 2, and it states that students will demonstrate an understanding of physical and chemical properties. So you're going to want to know the difference between the two, and you're going to want to know how atoms or elements combine. So first of all, let's look at a couple definitions you should definitely know. Probably could have put these two words together. If I look at this one and if I look at this one, how are they connected? If you said, well, a solution is a mixture, you're absolutely right. So what do we know about mixtures? One, we know that mixtures can easily be what? Separated. So for example, if I had some Chex Mix, you can easily separate the pretzels from anything else in them. A solution is slightly different. It's a mixture, but it's something that's mixed evenly throughout. For example, iced tea. I had some iced tea when I got home today. So iced tea would be a solution. It's mixed evenly throughout, where mixtures are not necessarily mixed evenly throughout. A couple other words, the difference between compounds and molecules. For example, molecules are simply combined atoms, where compounds is usually the combination of two different atoms. Now, how can they be different? Well, for example, H2. We know that it's not H2O, but just H2. Hydrogen doesn't want to be by itself. So a lot of times it will combine with itself. Or O2, this is the oxygen that we breathe. We don't breathe pure oxygen. These are going to be molecules. They are a combination of two atoms that are combined together. Now, a compound is when two different atoms combine together. Now, for example, H2O is a compound. It's also a molecule, but these right here are not compounds because they're both the same element. So these are molecules because it's combined atoms. This is a molecule, but this is also a compound because it's different atoms combined, where this one is not a compound. Now density, do you remember what density is? First of all, know that density is a physical property. Why is it a physical property? Well, it's a physical property because let's look at it. What's the equation for density? Remember how I told you how to find this? Put a heart with an arrow through it. Remember the story I told you in class about broken hearts? Well, again, if you don't remember that, remember it's mass divided by volume. So think of the M. Let me grab a different pen and I'll show you. So remember the M up here. Oop. Sorry about that. I moved the whole thing, didn't I? So remember the M and remember the V. It's mass divided by volume. And mass, that's a physical property. Volume is a physical property. Physical properties are things that can be measured and or observed. So both of those are definitely physical properties. Now, this is something you're going to have to be able to do. And we've done some reviews of these on the board. Now, the neat thing is when you get a test, first of all, make sure you read everything. So when you look up here, read, make sure you know what's going on. And a lot of times on our tests, we will give you examples. So this whole row right here is an example. And it even says example, MgL. Number of elements. Well, there's magnesium and there's oxygen. So 1 plus 1 is 2. So let's look at this. There's what? Hydrogen, oxygen. So how many are there? 2. Okay, there's carbon, there's hydrogen. So how many are there? There's 2. Okay, now name of the elements. Now this is where I'm going to have to try and squeeze this in here. Hydrogen. Okay, and oxygen. So let's look down here. C is what? Carbon. And we got hydrogen again. So let's look here. Number of atoms of each element. Okay, do you see how there's one of this and one of this? So how many hydrogen are there? There's 2. How many oxygen are there? There's 1. Why is there 2? Well, this subscript here means that there's 2 of this. And because there is no subscript here, it just means there's 0, right? Ah, did you catch that? No, that doesn't mean that there's 0. Let me erase all that and let me get that purple back up here. What that actually means is there's 2 hydrogen and how many oxygen? 1, because if there is no subscript, it means just there's 1. So when we look at here, carbon, there's 1, hydrogen, there's 4, right? Wait a minute, did you see something? What does this mean? What that really means is that there is a CH4 and there's another CH4. So how many total carbon are there? 2. So I'm going to have to fix that, and I'm going to have to put 2. So there's 4 hydrogen here and 4 hydrogen here, so total, what's 4 plus 4? There's 8. So make sure you look to see if there's any coefficients in front. Okay, total number of atoms in one molecule. Total number of atoms. Well, here, 1 plus 1 is 2. 2 plus 1 is 3. And 2 plus 8 is 10. Make sure it almost looks like that's a 1 there. Let me erase that whole thing and, well, not erase it, just cross out and put an 8. So make sure you look at these. Now, these aren't going to be the exact ones that are on the test, but make sure you look at the examples you see here. And I would suggest you go down and do this column, then this column, then this column, then this column. But you have to look at the examples. I'm always surprised at the number of students, you guys, that don't look at the examples and you do it totally wrong, where if you just would have looked at the examples, you would have done it right. Now, on this test, you're going to have to be able to create one of these, and you're going to have to be able to create one of these right here. Now, do you remember what this is called? This is called a Bohr model, and this is called a Lewis dot diagram. Now, in order to get the Lewis dot diagram, typically you have to do the Bohr model. You don't have to. There's a quick way, and we talked about that in the last review. But you notice there's also some vocab words up here. These are some things you're going to have to know. So, covalent bonding versus ionic bonding. Do you know the difference between them? Think of covalent. Co means together. Covalent means sharing. Ionic bonding is the transferring. So covalent bonding, they share electrons. Ionic bonding, one will give up its electrons. Know the name of the shells. You got the KLM. So know that this inner one is the K. L, the outer one is the M. In the last test, some of you were going from the outside in. Can't do that. Shells and orbitals. Each one of these is called a shell. It's the K shell, it's the L shell, it's the M shell, or it's the K orbital, L orbital, and the M orbital. Valence electrons are only those on the outer shell. Valence electrons are all electrons in the outer shell. And what's an ion? Do you remember what an ion is? Well, if you have a covalent bond, you're sharing electrons. But if you have an ionic bonding, you're giving up. So if you give up an electron, now all of a sudden you have a positive charge. You're an ion. Ions are electrically charged atoms. Or if you give up an electron, the other one that you're giving it up to, it has one more electron. Now it's a negatively charged ion. So here's magnesium. Does anybody remember the atomic number for magnesium? I'm looking at it over here. If you said 12, you're right. So in order to do a Lewis dot diagram, you have to be able to put the electrons in the correct shell. So we know the K can hold up to 2, so I'm going to put them in here. The L, do you remember how many it can hold? It can actually hold up to 8, right? So I'm just going to spread them around. That's 3, that's 4, that's 5, that's 6, 2, 3, 4, 5, 6, 7. I didn't do a good job of spreading around, but there's 8. Now if there's 8 here and there's 2 here, that's 10. So how many do I have left? 2. So I'm going to put 1 here and I'm going to put 1 on the other side. Now, the Lewis dot diagram or the Lewis dot structure, it only uses the valence electrons. So I'm going to look over here in the outer shell, and there's 2 dots, right? So I'm going to put a dot here, and it really doesn't matter what side you want to put it on. And I'm going to put 1 on a different side. Because it has 2 dots, it has 2 valence electrons. And knowing the Lewis dot diagram actually helps you when you are trying to figure out if it's an ionic bond or a covalent bond and how they share electrons. So make sure you can do this on the test. Come and get help from me early if you're having trouble with this. I'll run you through, I'll give you a couple more examples, and we'll see how you do on them. All right, next. Do you remember this from our lab? Well, depending. We're not doing this until the Monday before the test. So if you looked at this review over the weekend, you will not have gotten this to this lab. This is the last lab we're going to do in this unit. But just read it. It's just a logic puzzle. Based on the following data, rank the 3 solutions in order from most dense to least dense. So we had 3 trials, or 3 tests. Test 1, test 2, and test 3. And what we're doing is we're looking at relative density. We're not actually finding the density of these liquids. You're looking at how dense is one relative to another. So red versus blue, trial 1. Blue was more dense than red. So the blue one, I'm going to circle it, was more dense than the red. Second one, red versus green. The green was more dense than the red. Blue versus green. The blue was more dense than the green. Now, you notice we have a blue here and we have a blue here. So the blue is greater, more dense than the red. The blue is also more dense than the green. And the green was more dense than the red. So if I was just to go here, I would say, okay, the red, I know the green was more dense than the red, and the blue was more dense than the green, right? And the red. So this would be the order. So when it asks for the most dense, I'd have to say blue. And the middle density would have to be green. And the least dense would have to be red. So we're going to be doing a lab that's going to have you do this, and you're going to have to actually calculate the relative densities yourselves. You're going to have to actually pour the liquids into each other. And what you do with this is you just pour 2 liquids together. And if you poured them into a cup, let's say you poured the red liquid in, and the red liquid is on the bottom. So then let's say you poured the green liquid in. And if you poured the green liquid in, what would happen is if the green was more dense, it would stay on top. If the green was if the green was more dense, would it stay on top? I should ask you that. No. What would actually happen is it would invert. That green, because it's more dense, would actually go down. And if you left it for a while, eventually you'd see the green here on the bottom, and you'd see the red on top, because the red is not as dense. Because the green was more dense than red, it's going to sink to the bottom. So again, we're going to do this lab. Make sure you can do this for the test. And it really is a logic puzzle. You just have to look at there. What I'd strongly recommend is you write it out. Now, the last question that I want to review before the test. Now, first of all, have you seen this question before? You should say yes. You've actually had that question since the beginning of the unit. You guys always get the short answer questions ahead of time. So this is the question you're going to see on the test. And this one will be on the test. So let's work through this. This may take us a couple minutes. First of all, it says an amateur boat builder built an aluminum boat with the following dimensions. So this is going to be some important information right here. We got the length, the width, the height, and the boat mass. Now it says he needed to determine if the boat would float before he put it in the water. Water's density is 1.0. Explain how the boat builder should determine whether the boat will sink or float before he puts it into the water. So it says be sure to include your calculations for volume and density. Okay, so explain how the boat builder should determine whether the boat will sink or float. Well, first of all, I have to find my volume. And here's the thing. It says how to find volume. Length times width times height. So I might write down, okay, I got 10. I need to multiply that by 2, and I need to multiply that by 2. So 10 times 2 is 20, times 2 is 40, right? Okay. Now I know my mass is what? 100 grams. And I can put this, now if I label this, it's volume, right? So it'd be cubic centimeters. So now, how do I find the density? Well, it's mass divided by volume, right? So I have to go, the mass is 40. The volume is what? Oop, I got these backwards. Let me actually erase that so I don't get you guys confused. Let's go with a different color pen. Let's go with blue now. So what is my mass? Do we figure that out? My mass is 100. My volume is 40. So what's the answer to that? Well, just do the math. How many times does it go in there? 2. That's 80. And then you have 2, so it'll be 2.5. So it'd be grams/centimeters cubed, right? So it's mass divided by volume. Mass was 100, volume is 40. I do the math, it's 2.5. Now, this is how it says, explain how the boat builder should determine whether the boat will sink or float. Now down here it says, explain why the boat sank or floated. Well, if the density right here is 2.5 grams per cubic centimeters. Okay, now I've got a problem. Here it's 1. This is the density of water. Anything greater than the density of water should sink. So I should say the boat will sink because its density is greater than 1. And that's all I really need to say, because once I know its density is greater than 1, it will sink. Now this does conclude our review. So I really hope you watch this over. If you watch this over and you can do everything in this video, you will do well on the test. And as always, if you have any questions, please feel free to come in early before school, during lunch, or after school, preferably before the test, and ask questions so you'll do well on the test the first time. Thanks. Bye.